You have to love the eerie background of coming in, like it's like a nice coming on stage soundtrack. I'll start using that with my lectures. Århus students, be aware. Good morning. I hope everybody's enjoying Transmediale so far. I am a lot. All right. Wait until you hear the actual talk, then you're going to applaud. My name is Jussi Parikka. I'm from Århus University. I've got really an honor. I'm here standing basically as a fanboy. I'm here basically standing as a fanboy of our speaker today and giving a really brief introduction to what is going to be a really great talk. I got the really big pleasure of introducing and being in conversation with Laura Kurgan, whose work I really, as mentioned, immensely admire. She's a thinker who helps us to think architecture beyond buildings, who helps us to think remote sensing beyond technology, and who helps us to think about contemporary cultures through space and the ways in which we develop methods to think space in critical sets. This will be her talk today as well, multiple scales of thinking about space and technologies, but beyond technology. Laura Kurgan is Professor of Architecture and Director of the Computational Design Practices program and Center of Spatial Research at Columbia University in New York. You know her from books like Close Up at a Distance, Mapping Technology and Politics that came out in 2013 already, and also co-editor Ways of Knowing Cities. We also know her from multiple kinds of artworks and installations, but I'm not going to start introducing them. I instead want to really make sure that Laura has plenty of time today, so let's give a warm welcome to Laura Kurgan.
Okay, thanks so much, Jussi. And I'm really thrilled to be here at Transmediale. This is my first time presenting here. So, oops, let me just see. Hold on. Get this going. Okay, so just quickly to let you know that I'm presenting. Are the lights going to go down? A new project today. So you're going to see work in progress, and I'm really looking forward to my conversation afterwards. But this is the range of work that I've been working on over the last 10 years or so at the Center for Spatial Research. We are a critical cartography center, and we make links between the data sciences and the humanities, and the sciences as well. We do a lot of work in collaboration with many people across the university and outside of the university. And the work that I'm doing today started in collaboration with the Mind-Brain Behavior Institute. It's actually now called the Zuckerman Institute in the Jerome Green building at Columbia University. I don't know if Jochen Hartmann is in the audience. He worked with me and the scientists for about 4 years on a lot of the images that you'll be seeing today. Okay, so I'm going to start. Navigation has typically involved something more technical than biological, especially in relation to traversing and remembering spaces. From compass, map, astrolabe to GPS, humans have relied on a variety of devices to get themselves or their projectiles from here to there. But these tools are not the only game in town. Biological navigation, in fact, is crucial for the everyday life, movement, and survival of a myriad of species. Nowadays, this interplay between the technical and biological navigation is increasingly blurry. But what are the characteristics of navigation that we encounter along the gradient between the technical and the biological, between positioning and memory? To answer this, I'll put the discourse of cognitive mapping, which is kind of haunts my field of study, into dialogue with advances in neuroscience and artificial intelligence, where scientists are now routinely talking about GPS for the brain. I'll try to account for a few important misalignments in the metaphors used to describe how the brain works, as well as revisit and critique the influence of cognitive mapping in architecture and urbanism and human-computer interaction today. I'll account for the research embedded in these binaries, which have resulted in multiple images of the brain, technologies of imaging them, and a range of diagrams explaining how they work, and a series of metaphors which describe them. We are living in a moment when artificial intelligence threatens to absorb and replace many fields, disciplines, and control systems with increasing speed. Simultaneously, the technologies and algorithms that aim to simulate the biological brain and want to exceed its capability still can't map the brain of many species, including and especially the human brain. Researchers still claim that the human brain is the most complex organ, a network of trillions of brain cells or neurons housed in a jello-like framework. So I'll begin by asking, what are the relationships between the technology and biology that build the images and networks? Networks are only one way of describing brains, but there are a number of models of the brain: functional, vascular, connectome, the brainbow, and more. There is a grand tradition of making art out of human anatomy, writes Carl Schoonover in his Portraits of the Mind, from the comic, and quoting, from the comic grotesqueries of Vesalius to the exquisite line drawings of Kayal, the 21st century is no exception. Just because these images depend on expensive machines doesn't make the scientist a passive observer, nor one that thinks only about aesthetics. So I want to start with such artistic and, of course, paradigmatic scientific moments in the history of imaging the brain, and the metaphors used in describing the work of the scientists in the press releases of 2 Nobel Awards for physiology or medicine awarded for neuroscience. In 1906, the Nobel Prize in Physiology and Medicine was awarded, in the words of the Nobel Committee, to Camillo Golgi and Santiago Ramon y Cajal for revealing the inner beauty of the nervous system. By developing methods that could color and highlight its key components, Golgi and Cajal allowed the anatomy of the nervous system to be observed and documented in precise detail. Unquote. The drawings were made from staining the physical brain by Golgi and by drawing from memory after looking at neurons in a microscope by Cajal. And the sheer beauty of the brain they draw is hard to argue with. Just over 100 years later, in 2014, the Nobel press release got a little more prosaic in describing achievements that led to the prize that same year. How do we know where we are? How can we find our way from one place to another, they asked. And how can we store this information in such a way that we can immediately find the way the next time we trace the path? This year's Nobel laureates have discovered a positioning system, an inner GPS in the brain that makes it possible to orient ourselves in space, demonstrating a cellular basis for a higher cognitive function. That's the quotation from the Nobel Prize again. So how do we account for this shift from our inner beauty to our inner GPS, from a biological description of the brain to a technical and dynamic description for GPS navigation? I have a longer answer, but for now, let's say that although scientists are still making sublime images, the metaphors have shifted from aesthetics to the socio-technical ways in which navigational tools have actually had a tangible effect on our brains. At this point, I'm sure you're all asking where this is going. Why am I interested in these metaphors? They are in sync with some of my own obsessions about the misalignments between technology and science and society that have led me down the path of trying to understand and critique navigational technical systems by using them, not from some critical distance, but from an ordinary experience of working with them. I have a small claim to fame that in 1994, I produced what seems to have been the first art made with GPS as a drawing tool. The first version of this work was displayed at New York City's tiny storefront for art and architecture, with its large reputation of showing experimental art and architecture. Very few people had heard of GPS in 1994, although it was heavily marketed by a few companies in the habit of spinning off military technology as the next utility. It certainly has become that, and my installation was about the architecture of the system that makes digital maps, and the fact that you had to receive a signal from a satellite in outer space in order to locate yourself by way of a GPS receiver on Earth. I wrote about and displayed the stupidity of a machine, which, by way of communication with a stationary receiver, kept drawing the same point every second, jumping around the screen with a range of uncertainty. It never got tired of drawing the same point within a range of inaccuracy. I was also commissioned to do a project again in Barcelona in 1995 for the opening of the Museum of Contemporary Art in Barcelona, colloquially known as MACBA, designed by Richard Meyer in the old part of the city. I used a GPS receiver while walking on the roof, tracing the letters of the word museu as I walked across the gridded space of the roof thanks to Meyer's modernist grid. I had a frame in which I could trace digital letters, and I asked questions about the so-called perfection of the Maya grid compared to this dynamic mapping tool, which could not get the lines quite as straight as he would have liked. But the point was that the maps pointed mostly to the coordinates of the map, and not of the city or of his building, for that matter. So jump to 2014, almost 20 years later. I was working on a brand new project about mapping the human brain and modeling its connectome structure. Our team were working with scientists at the Mind-Brain Behavior Institute to communicate it as a networked model of the brain. You can only imagine my surprise when 3 scientists, John O'Keefe, Edvard Moser, and May-Britt Moser, were awarded the Nobel Prize for Physiology or Medicine in their work on navigations in our brains, and that this was called our inner GPS. They had moved from a discovery of what O'Keefe called place cells in 1970. They had discovered from a discovery of what O'Keefe called place cells in 1970 for what they were calling grid cells in 2005 and beyond. By 2014, no one even needed to ask what GPS stands for. We rely on it daily on our smartphones and dashboards to navigate our way around. Even when we know the roads, GPS and the many maps bearing the names of tech corporations guide us to the fastest route or the cheapest one to get to where we're going. Both scientific and popular pieces about the discovery of grid cells referred to the dynamic cognitive maps which people and animals produce and reproduce as they navigate through their daily lives. Accounts for the general public were mostly fascinated by the idea that the brain had a little machine in it. The scientists, however, were talking about navigation and spatial memory and about how humans and animals remember space at all. They say we can't survive without a memory of space to orient ourselves. It's important to keep in mind that GPS is a machine. It does not remember anything. It is simply a system that connects satellites to receivers and identifies momentary locations in longitude and latitude. When GPS is connected to other devices, like phones, cars, or control centers, then the data it generates can be transformed into data as a spatial memory with a date and time stamp. So, how are cognitive maps formed in our brains? In biological terms, the cells in our brains, neurons, communicate in very particular ways. It is an axiom of neuroscience that neurons that fire together wire together, which is to say that they form specific connections that create networks in the brain. Firing means sending electronic signals across voids called synapses, little tiny gaps. An explanation of place cells and grid cells can help orient us in the science and metaphors of cognitive mapping. It will allow us to read the complexity and underlying differences between the metaphors and the science of the ways in which we make pictures inside of our brains of the space outside of our brains. We owe the notion of cognitive maps to behavioral psychologist Edward Tolman, who invented the term in 1948 to explain the conceptual and spatial map created in the brain of a rat to remember its way through a maze. In describing the brain of a rat, Tolman says that the central office itself is far more like a map control room than it is like an old-fashioned telephone exchange. This is 1948. What an apt metaphor of a cognitive map-like of the environment. 2 decades later, John O'Keefe found the cells of the brain that help form these cognitive maps and called them place cells, and located them in the hippocampus, the physical part of the brain associated with memory. Navigation through cognitive maps in these experiments was related to learning and remembering space. Place cells fire when you are at a particular location and encode information sequentially, meaning that one can retrace a particular journey by going through a list of place memories in sequence. From a rat's point of view, leaving the basement, turning left, scuttling to the fire hydrant, knowing that facing this way or that means filing a pile of garbage bags in New York, and hence you're headed in the right direction for dinner. As the Nobel Committee described it, the place cells report the position of a rat and build up an inner map that represents a mental picture of the environment. O'Keefe suggested that a place may be stored as a specific combination of place cell activities. In 2005, Edvard and May-Britt Moser looked outside of the hippocampus to understand navigation in the brain. This led them to the entorhinal cortex of the brain, what Edvard called the unknown territory. Edvard says, "We put electrodes in that part of the brain in rats and recorded activities. In an environment where the cells are very active, you will hear this really high-pitched popcorn sound, and it allowed us to record patterns." They described the grid as an empty map, like longitude and latitude without the map, just a coordinate system. A strange but familiar formulation, it implied that the grid had no knowledge of an actual place or what it looked like, only that an animal had a position and a speed. They said, maybe you can say that the grid cell's similarity to a GPS system is that it uses the rat's position and movement and speed, but doesn't care about what its environment looks like. It only uses the change in position, just like a GPS. So as I've described earlier, GPS will not stop drawing points until you turn it off. Same with our brains. They just keep drawing and redrawing maps like coordinate systems relative only to a starting point, a kind of dead reckoning. Only speed and direction are part of this coordinate system relative to a starting point. I'll return to this later. The Mosers did not forget about place cells, however. Reiterating the importance of the network model of the brain, the scientists explained that there is a communication between the entorhinal cortex and the hippocampus when you have a specific memory. This is the memory of landmarks, of the environment, of everything that is layered on top of the abstract coordinate system. They explain, of course, the difference in the navigation system in the human brain as compared to GPS is that it's so much more. The area that contains grid cells happens to be the same area that is first damaged in many Alzheimer's patients. These same scientists studied the brains of London black cab drivers in 2006 and discovered that the legendary 3-year-long knowledge test, combined with their years of experience driving taxis, enlarged their hippocampus, and when they retired, the hippocampus shrank. The Moses work went further to open up the kinds of neurons in the brain they call cells, grid cells, place cells, border cells, edge cells, which are all activated in different parts of the brain and communicate with one another to create a neural spatial system of dynamic cognitive maps of varying degrees of abstraction and specificity. Only place cells remember and learn with any specificity about an environment, while grid cells and the rest are empty of specific environmental content, just like GPS receivers. They register navigation of any movement independent of describing a specific environment. The Nobel press release continues, grid cells and place cells have opened up new avenues for understanding other cognitive functions, such as memory, thinking, and planning. The new science of the mind is also very popular amongst architects and planners these days, particularly by the designers and critics who claim to discover in neuroscience a set of fundamental human traits and who use them as a standard to criticize the current state of the built environment. There are many presumptions and ideologies embedded in a simple juxtaposition, for instance, one that labels Times Square as cognitive overload, or an image of a cul-de-sac as suburban blues, or as a numb landscape. There are many interesting things architects can do with neuroscience, but these conservative cliches are poor instrumentalizations that hide from the radicality of these discoveries. We need to ask how questions of orientation, location, and navigation are relevant to the vibrant questions of learning and curiosity, and therefore memory. These are familiar themes as well in the canons of architecture and urbanism. In 1960, Kevin Lynch picked up on Tolman's behavioralist concept of cognitive maps in his seminal, if problematic, book, The Image of the City. In it, he interviewed people, only 25 for each of 3 cities, and asked them to draw mental maps of their city as they remembered it. In it, he focused on the legibility of the American city, and proposed that in the process of wayfinding, the strategic link in the environmental image, the generalized mental picture of the exterior physical world, is held by an individual. The image is the product of the immediate sensation and memory of past experience, and it is used to interpret information and guide action, he says. Lynch went on to propose that these mental maps of the city could be reinforced by paths, edges, districts, nodes, and landmarks in order to be more effective in terms of navigation and what he calls sense-making, and they could also contribute to what he calls good city form. Architects and urban designers worldwide have used these principles, but in fact, Lynch, and it's very seldom talked about, was talking about the illegibility of the city, particularly in the chapters of Los Angeles and New Jersey. When you need wayfinding signage, he says, mental maps are not formed and urbanism fails. Wayfinding is a stand-in word for Lynch, for navigation, and mental maps are a kind of cognitive map. So this is New Jersey and LA. Technologists have been equally influenced by his ideas, symptomatically as metaphors. Human-computer interface designers, HCI, learning from Don Norman and his design thinking methodology, use Lynch's universal concepts as the most common and necessary metaphors of space in navigating complex digital interfaces, with no questioning of the principles or his methods of defining them. Frederick Jameson, equally influential in the reconsideration of Lynch in his postmodernism essay, rejected the premise of these cognitive maps that formed with such simple, legible images and so few criteria were either necessary or universally shared. He says about Lynch, Lynch suggests that urban alienation is directly proportional to the mental unmappability of local cityscapes. A city like Boston, then, with its monumental perspectives, its markers and monuments, is a combination of grand but simple spatial forms, including dynamic boundaries such as the Charles River, not only allows people to have in their imaginations a generally successful and continuous location to the rest of the city, but in addition gives them something of a freedom and the aesthetic gratification of traditional city form, unquote. Jameson proposed that contemporary urban space was too complex simply to be mapped. And instead of taking legibility as a given, it generated something like an imperative, and I'm quoting again, to grow new organs, to expand our sensorium, our body, to somewhat new and yet unimaginable, perhaps ultimately impossible dimensions. Think about those London cab drivers again. Jameson did not read anything about grid cells, but might have been predicting their existence as well as a multidimensional view of cities. Multidimensionality is at the core of neuroscience today. To enable people to see neural networks implies limiting their dimension, which means hiding dimensions, such that ideas about complex networks might be explained. But as an analyst of late modern capitalism, for Jameson, coordinate systems can never be empty in relation to urbanism or spatial theory. It is the outcome of social and economic forces. Maps have agency in the formation of those spaces. In the last paragraph of his essay, Jameson's challenge is that, quote, the political form of postmodernism, if there ever is any, will have as its vocation the invention and projection of global cognitive mapping on a social as well as spatial scale. Jameson could not have been more accurate as people, money, and things have moved around the world at increasing rates of speed from the 90s until now. Maps which visualize global data have made visible the scale of so many patterns. Many geographers, cartographers, and data visualization artists have knowingly or unknowingly taken up this challenge and created global cognitive maps, including myself, while always critiquing the ways in which data is deployed to empirically describe the world in which people, animals, and environments are situated. From lights at night to endangered languages, which coincide with endangered ecologies, I've tried to show the gaps in global phenomena rather than their connectivity. In the world where the digital has, in some ways, colonized the physical, how should we re-theorize cognitive mapping? And is cognitive mapping even a useful category for describing the ways in which we understand and picture the world to ourselves? So back to the scientists. In an article on parascientific mediations, Ranjad Singh Dhaliwal, who I think is here at Transmediale, helps us locate, as it were, the question of navigation within the broader topic of neural networks. He says, and I quote, "On the one hand is the neuron, colloquially understood as the thinking cell in most animal species. On the other hand is the artificial neuron, understood analogically as a biomimicry instantiated in the silicon computational hardware. Both figures in this story are separated by almost a century. This gap is not a historical given. The ties between a neuron and an artificial neuron get inaugurated right in the middle of the 20th century, after all, but instead a choice made here to illuminate some specific transhistorical features of and maneuvers in thinking about thinking," unquote. Dhaliwal and I are talking about the same century, and we and other authors in the same book he is in, Neural Networks, which someone mentioned yesterday and I highly recommend, are writing critically about multiple models and, dare I say, cognitive maps of the brain. The book has 3 articles, and the contents are also bracketed by a century to include Golgi and Kayal, who discovered and pictured the inner beauty of our neurons, and John Hopfield and Geoffrey Hinton, very recent Nobel laureates from 2024, who were celebrated for their work on machine learning or artificial intelligence, which can simply be explained as the brain-computer analogy. The work is described this way, and I quote again from the Nobel press release. When we talk about artificial intelligence, we often mean machine learning using artificial neural networks. This technology was originally inspired by the structure of the brain. In an artificial neural network, the brain's neurons are represented by nodes that have different values. These nodes influence each other through connections that can be likened to synapses and which can be made stronger or weaker. The network is trained, for example, by developing stronger connections between nodes with simultaneously high values. The key word here is inspired by the structure of the brain. We have another abstract model of the brain diagrammed as artificial neurons working in a network. These networks are very difficult to navigate. We can diagram their inputs and outputs, but their inner workings happen in layers of connections between nodes, some visible, and as you can see in this diagram, some hidden. And the content of the hidden layers are used to train the next machine. Artificial intelligence is used to analyze the world, to make predictions about it, the weather, the stock market, conflict. AI is used in hiring people, controlling borders, military targeting. And AI is also used creatively, generating an easy facility in the creation of 3D images. And it also finishes our sentences for us if we let it. And if it's correct at all. All of this has been analyzed and critiqued, showing its biases and its dangers and its possibilities. Even its hallucinations have been used artistically. As the research grows, so does the research about pertaining to the guardrails necessary to counter these dangers. So over here I'm showing a project by Beth Coleman, No Innocent Models, where her hidden layers are called the artist controls. It's really a fantastic thing, and she accepts the hallucinations, the incorrect interpretation of the imagery she's asking for, to present these artistic images. But again, all this is all just a metaphor for how our brains work. Our inner GPS is too cold a metaphor for the range of functions and feelings that constitute a human brain, or any brain. How do we navigate between these biological and artificial neurons so that they inform each other multidimensionally with multiple metaphors? The navigation of any living animal is consistently drawing cognitive maps in their brains, grid cells and place cells. We can't see them. We can only diagram them. We can only see diagrams of them. And as diagrams, grid cells are vacant of any content. They only know our speed, borders, edges, direction, and place cells record the specific things, places, and memory. The artificial brain of any system is also consistently drawing neural networks, input and output diagrams, including layers of working nodes in between. Can we call these cognitive maps of their systems? We can't see them either, especially their hidden nodes. Other neuron networks, biological and artificial, are traces of a past. Still others are predictive of a future. And all of these are strengthened and weakened by the ways in which they learn and are trained. Collectively, this is the brain of the present. Navigate cautiously. A lot is at stake between the biological, the technical, and the political. Thank you.
The table is a bit far. Let's get it closer. Let's get you a mic as well. Let's make you comfortable.
Can you hear? Yeah.
Shall I open a bottle?
Some water.
Yeah.
Thanks. Okay.
Welcome to our performance. 2 people drinking water on stage. Right, let's jump into it. Thank you so much. That was absolutely fantastic. I'm going to get my phone here as well to keep time. What we'll do is a conversation. We'll follow up on themes that were part of the talk, but also themes that you sort of hinted at. Didn't have time to go in depth, and then if we have time, we'll also open to the audience as well. And if there's not enough time, please afterwards come and talk to Laura, okay? Now, just as a brief prelude as well, I was listening to your talk and thinking of this, and I want to say it's the philosopher A.N. Whitehead, but people in the room might say that no, it wasn't. I can't remember now. Who had a really nice line about navigation and being lost. In the middle of being lost, the usual question is, well, it shouldn't be, is where am I? But actually, where is the rest of the world? And what is my relation to the rest of the world? That might be more helpful. And that sort of is a nice way of also thinking about the brain that is located, but also is constantly projected. The things that you mentioned resonate a lot with the new cognitive sciences for decades, of the extended brain and the ways in which the brain is already out there as well as the weird ways that the metaphorics reproduces brains as computing devices across spaces of different scales. I like, even if it's metaphorical, I like the sort of ways in which the weird scales of the planetary orbit becomes reinserted into the brain, and the brain becomes reinserted onto the orbit. And that sort of leads into really lots of interesting ways that we need to unpick the technological mandate there as such as well. Now, let's talk a bit about those topics, but I also want to start with a bit of a transmediale crowd pleaser. When you come to transmediale, we often talk about glitches and when things don't work, errors and such things, right? It's something that features in your talk as well. You mentioned things like inaccuracy. You are interested in gaps in knowledge. You mentioned illegibility and those things as well. What is the role, what do you think is the role of such misses or gaps, inaccuracies in perhaps evaluation of technology, but potentially also in the pedagogy and the ways in which you think this with others, for instance, with students? Right. Can you talk about your interest in these kind of topics a bit? Okay,
all right. I think there's about three topics embedded in what you're talking about. You know, getting lost, the gaps, and teaching. So let me start with getting lost. I'm a big proponent of getting lost, and in fact, my first book and all my first projects were about the necessity of getting lost. And and that was when GPS was just emerging, and nobody even knew what it was, and all it could do was draw 1 point per second. So the claim that it was there to orient us was in fact, a metaphor. Although, today, linked to our smartphones, all the mistakes that happen through navigation, where it leads you to the edge of, some place you're not supposed to enter, but the road, keeps going, and you end up going through a checkpoint. So there's all kinds of things like that. But I do think turning off our GPS for a while and walking around cities is still some of my best occupations, and getting lost. And I'm very good at getting lost, even with the GPS. And then the gaps. Really, every data set that I've ever worked with has gaps in it, and it's the same kind of claim. Everybody thinks that data can describe the complete worlds in which it's attempting to register or record or all of those things. And so many of the projects that I work on, and I worked on for 10 years a project on conflict urbanism in all kinds of scales, and from war to just ordinary everyday life conflict, that there are gaps in those data sets. And I try to account for the gaps rather than to erase them, because it's in the gaps that the politics of the data really emerges. And then, of course, to continue that metaphor, in the brain, the synapses, these tiny little gaps where you only can make networks and connections across gaps and across voids. So the gap features in my work in a lot of different ways. And And then in teaching, I've just started a new program, Computational Design Practices, and we go right back to basics in our work, and we ask, what is computation, what is design, and what is spatial computing? And if you ask a group of architecture students what is design, not one of them will have an answer. And so much of the way in which we design incorporates imagination, yes, but software and all the tools that are available to us, which have politics, which have constraints, which have limits, which have measures, right? So we really start from there in trying to put together computation and spatial computation through design and ask questions about what all those things mean, what it means to bring all those things together into a project.
Exactly, and the sort of ways in which you describe this is critical pedagogy of the introspection as well as the investigation of the context in which all of the knowledge production happens. So it's really there's something about that you're interested in maps. I mean, you work with maps in all kinds, but it's maps of gaps.
Right.
And is it then also about developing methodologies of knowing about the unknowing, in other words, the ways in which we map the gap, but without reducing its, reducing its nature as such, and not sort of projecting everything into a hegemonic knowledge structures as such. Is there something about pedagogy and the methodology there about that as well?
I think so. I would never write a book like Kevin Lynch's. I would never, ask for a set of universals that students or architects should use in creating cities. So I think when I continue with this work, I will obviously start asking what cognitive mapping might mean for architecture today, or is it an okay strategy for doing that? I do think in the end I would probably come down on saying, well, yes, it is important because we are constantly translating, the world into our brains in some way, but, in very incremental ways, and we're doing it all the time. So, maybe there are other ways of thinking that through in terms of what it means to traverse space and inhabit space and design space.
Yeah, and that sort of leads me to one thing that I was also interested in, among many things. But like you mentioned, Frederick James, and you mentioned that note about growing new organs for sensing as well. And a lot of the things you already said here as well implies not just working with data, but also working with sensing in a particular kind of way. Obviously, and again, as you heard, a lot of this at the very core of this year's transmediale themes. But like the remote sensing is there, but you're interested in various modalities of sensing, right? And I also want to say that there was something nice that was there in the talk about non-human sensing. You had the rats, you had a bit of insects there as well.
Yeah.
Does that feature in the sort of like ideas of what sensing even is, and sort of also,
Yeah, definitely. I mean, one of the scientists that we interviewed when we were working on this project, his name is Dmitry Aronov, and he actually studies birds, not rats and mice. And he says, neuroscience has been influenced by 100 years of studying rats and mice. We need to go further. And he does this incredible research about birds which hibernate, and before they hibernate, they put food in a sort of a territory, in a contained territory. And when they wake up, they remember exactly where all those. But sensors, going back to the theme of the biological and technical, we see, hear, smell, taste, can't remember the fifth one, and then there's all kinds of ways in which, in a McLuhan-like, extensions of ourselves, we have satellites and we have, the Internet of Things and all kinds of ways in which we are being aided in sensing for bad reasons and for good reasons. And, all those, and we also track animals and, to save tuna fish, from extinction, but for bad reasons, as well. So there's, all of that is collapsed, I think. That question of of sensing and remoteness really collapse into the same analogy of the brain and the metaphor of the brain.
I want to invite you also to talk more about, you showed some of your work also at the background as well. You didn't have a chance to talk about it so much. But the notion of the diagram is central. It featured centrally again, and it features centrally in your work, and it features and speaks to many of our works from different perspectives as well. This might sound a bit simple of a question, but I know that your answer will be really, really kind of helpful. Like, cognitive mapping becomes about diagrammatics. The diagram becomes a methodological tool. And it's somewhere, interestingly, like a lot of diagrams in general, between sort of a descriptive, things that are described in diagrammatics, and exploratory, even speculative. Yeah. How do you navigate across different knowledge functions, even aesthetics of diagrams? Yeah. Knowing also that you're working also with scientists, so there's probably all kinds of reasons that you have to go in certain routes and certain visualizations. Can you just unpack the ways in which you work and think and sort of with diagrams?
Yeah. Well, first, the work we were doing with scientists was to try and create a kind of public science. So we were trying to do a more explanatory graphics of the ways of the very abstract ways that oftentimes the scientists do their work. So that was one aspect of it. But in terms of diagrams in my own work, I'm obviously obsessed with making maps, but if you notice, I very seldom make a map with the outline of a country or a city or a state so the data itself makes the map, or the incompleteness of, you can usually read as a cognitive map the map that the data is being overlaid onto a space. And then I often, when I teach, I say, geographic information systems and geographic information sciences, we use software to make the maps, but it's not a software, right? It's more of an interpretation of space, that kind of layered stack that you saw in the diagrams of the rats' brains and the 3 different ways which things are networked together. The softwares in some ways replicate that kind of stacking as well. And we really have to take notice of the multiple dimensions of that stacking and the incongruities of the kinds of spaces that they're describing. They're not always synchronous or talk to each other in smooth ways. They're often very conflictual. And so, and my students, I'd say 20 years ago, they might have all used one software to produce a project. Now they use 20, and there's all kinds of workflows, and those kinds of ways of putting things together have a politics, and they're not neutral, and they interpret a space or actually have agency in creating interpretations of space. So,
yeah, and I'm really fascinated of what it does to our view of architecture. I mean, the view of architecture within those practices as well, in critical ways and in ways of thinking about its role, right?
Right.
We might have some time. We still have some minutes as well. So please, audience as well, if you have questions, we might have time for 1 or 2. Are there,
there's a hand in the middle.
We'll do it old-fashioned ways of hand up. And yes, there's
one
one there
hand
at
over
least.
there.
Right, exactly. I'm really sorry if I don't see everyone's hand.
And there's a hand over there too.
Oh, there's 2 questions already.
David,
yeah, good. All right, let's take him first.
Yeah, so thank you for taking the question. There's no doubt these visualizations they're fascinating. But as I begin to see these detailed maps, I can't help but begin to sort of fear how maps can often introduce the territorial and, at worst, the colonial. What are your thoughts about private enterprise like Neuralink and others that are seeking to commercialize this sort of data?
I definitely critique it. Yeah, I do. I've written a lot about critical cartography and the ways in which maps claim the spaces that they are describing. But on the other hand, there's very few spaces outside of the map. And especially today, when the digital has in fact colonized the physical. It used to be, well, I don't even think it used to be. I think virtual descriptions of landscape have always been in conflict with landscape, and the dialogue between the digital and the physical, or the mathematical and the corporeal, all those things have always been in conflict with each other, and I'm always engaged in that conflict. So I hope that helps, yeah.
Yeah, that's great. I think front row over that side, if we can get a mic over there, just over here, I think, unless I missed anyone, but I think it's your turn.
Hi, thank you both so much. That was really enlightening and engaging from both ends. Laura, earlier you mentioned, I love the phrase, the conservative instrumentalization of science, or of, I guess, specifically like GPS and these kind of frameworks. And it's something that I'm very interested in as well. As you mentioned Don Norman and Lynch, and also comes to mind Christopher Alexander, the way people are using these kind of universalist, like formulaic approaches. But I'm always afraid of discarding the intent, or not the intent, the value of some of what we can draw from science, but without pushing it to that conservative instrumentalization. So I think a lot of your work, you're using methods and outputs. And so I wondered if you could you say more about like how do you navigate that tension between an overly deterministic reading?
Oh, over there, when I was showing the Times Square and the suburbs, that was a website whose name is escaping me right now, but I will tell you after the talk. And also the book by Sarah Goldhagen, which is taking ideas from neuroscience to say we need to, design calmer cities so that, and I just don't think I might walk in Times Square with a friend of mine who will not get information overload at all, So I just think those categories of saying what does and doesn't work is the same as Kevin Lynch, and I just don't think you can universalize these kinds of things. So does that help?
Well, I'm wondering if you, like in your work, you're carefully threading the use of science with a critical stance. So that's kind of what I'm wondering is like, are there approaches or ways of thinking through this that allow you to limit that determinism or that overextension of the categories?
Right. Not really. I think I stay right there, right? I like to engage. I like to engage in that, in those definitions and countering them. And I guess there are worlds in which the science doesn't matter, but actually right now I'm scared of those worlds. I don't want to be in a world where science doesn't matter at all, right? I think you know what I'm talking about. Yeah.
Yeah, nice line. I echo that. I have at least one. We'll have time for one question at least, I think. Can we get a mic over here and relatively front? Just over here. Thank you. I'm sorry if I'm missing out people. It's my eyes.
Yeah, hi. Thanks again. It was really fascinating and really inspiring and informative. It's kind of an esoteric question. I barely remember about research about tribes who were much better able to navigate unknown spaces. So there were this kind of sketchy theory about us, let's say more civilized, who have repressed somehow some of our senses. So instead, let's say, of developing new organs, what's your opinion about trying to, let's say, pushing a bit our own sensing system in order to regain, possibly, hypothetically, these possibilities?
Yeah. Yeah, I think there's a lot to learn about navigation without technology. And in fact, one of my students right now lived in the desert for a whole year and taught herself to navigate by the stars and the moon, and is in fact teaching some of my students as well. I do think that, but that's also a technology, right? So, but it's a different kind of technology, and I want to learn from her, and I hope I have an opportunity. But so I do think, yes, we should multiply our ways of knowing so many things to deal with the problems and conflicts we're encountering today. Thank you for that question.
Yeah, no, that's great. We probably don't have time for one more. We can take one more question as well, if there's a quick one.
Yeah.
It's a great.
Can't see any hands. Are there any more hands?
Did anyone else?
Yeah.
There's one that over there. Two hands over there.
Yeah. Okay.
Over there.
Thank you. I actually have one question. I just had some support for visibility. So thank you so much for your talk. It was very insightful. I'm a neuroscience student, and
Okay.
Throughout my education, I've been presented with cognitive maps, especially of the visual system, which often represent very hierarchical models.
Yeah.
And now as I'm learning more and more about visual systems, it's becoming apparent that it is actually not as hierarchical as I've been taught along the years. And when it comes to data analysis and mapping, the brain, fMRI, all those technologies rely on so much reducing of dimensionality of data that it seems like it is very hard to communicate a more complex view of the brain, taking all these dimensionalities into account. And I was wondering also if you have any suggestions on how cognitive neuroscience could be taught in a way that represents this multidimensionality.
Right. Actually, thank you for that question. Multidimensionality is something I'm really interested in, and I'm not a neuroscientist, and nor am I a mathematician, so I don't 100% understand it as the math behind it. But conceptually, I'm really interested in multi-dimensional architecture and multi-dimensional urbanism, and using that idea to try and multiply the dimensions in which we understand the world, in which we traverse space and politics, etc. And I often ask neuroscientists to explain what multidimensional space means, and it's so hard for them. So I really understand what you mean by your question. They're like, oh, it's about flattening, it's about dimension reduction, but nobody can say what the 2,000 dimensions that they're describing, what exactly it represents. So it's something I do want to continue working on, and I don't know which neuroscientists you were working with, but I would be interested. I'm always interested in learning more about that mathematical interpretation of the brain and what exactly it means, and to explain it better so that I can transfer that into the architectural arena.
Wonderful. We're running out of time, but let's give one more time a really warm thank you to Laura.